Solution. We know that the beta distribution is a continuous distribution. So for the expectation of a continuous distribution, we have that the expected value of x is equal to the integral as it ranges from 0 to 1 x multiplied by f of x dx for a continuous distribution. So this function you see here and this are the same thing. The next thing to do is just to use the whole of this function and impute it into this integral. So what we have here is that our expected value of x will be equal to the integral as it ranges from 0 to 1 x multiplied by the whole of this function, which is 1 all over alpha beta multiplied by x alpha minus 1 multiplied by 1 minus x beta minus 1 dx. So this is what we get. The next thing to do is to rearrange this. If we rearrange this, our expected value of x will be equal to, we bring this out, we bring this function out, which is beta alpha beta into, as it ranges from 0 to 1, we have that if we combine these two, we'll have x alpha minus 1 plus 1 into 1 minus x beta minus 1 dx. Of course, this and this will give us 1 all over this into from 0 to 1 x raised to the power of alpha into 1 minus x beta minus 1 dx. This is what we get as our expected value of x. So of course, this is gone, we have this. The whole of this function implies the expected value of x to be equal to 1 all over alpha beta multiplied by the whole of this function will give us our beta distribution into alpha plus 1 beta. So it then means that our expected value of x is equal to beta distribution alpha plus 1 beta all over our beta distribution into alpha beta. The whole of this means the whole of this function will give us, if we use the gamma function to write this, we'll get gamma into alpha plus 1 beta all over alpha plus beta plus 1 all over, we'll write the function, this function will give us alpha multiplied by beta all over alpha plus beta. So this is what we get. So we come over to this place to rearrange this properly. If we come over to this place, we get our expected value of x to be equal to alpha plus 1 beta all over alpha plus beta plus 1 multiplied by, this will come over to this side to give us alpha plus beta all over alpha beta. Of course, this is the same thing as alpha gamma alpha beta all over, this is the same thing as alpha plus beta into alpha plus beta multiplied by alpha plus beta all over alpha multiplied by beta. This is what we get. This is what we get. So, of course, this can cancel this, and the whole of this can cancel this. So, it means that our expected value of x will be what is remaining here, alpha all over alpha plus beta. This is what we get. This is what we get. Now, for we to obtain the variance, we look for the expected value of x squared.